Hi, good afternoon. Wednesday Physiology Lab. How's everyone doing today?
Good, how are you?
Hey, Professor, I asked the lecture professor, Mr. Clark, where the lab Zooms are posted. Are they posted somewhere else? Because he puts it in the syllabus.
Yes, I post them on YouTube.
Oh,
There's a link to the YouTube site. I'm pretty sure, let's go take a look. I'm pretty sure I know where it is, but. Let's make sure. Yeah, I post mine on YouTube because I find the YouTube closed captioning is one of the better captionings. So here we are on the Canvas page in this module that's called All About Labs. Down here at the bottom, Lab YouTube site. And so for Wednesday's labs, you just click on this button and it'll take you to the web page. Anything else I need to address before we get started?
oh, I got it. I found it. Thank you.
You're welcome. Okay, I'm pretty sure that I have mentioned this one to you guys. The college is going to be remote until mid-February. Right now, it looks like our first, oh, somebody showed up. Our first in-person lab meeting will be the 16th of February. I think that's the right date. So it's going to cause a lot of changes in the lab schedule. And it's going to cause some changes in the grading plan. So what I can say for sure is that there will be 2 assignments each week for now. When we get back in person, we're going to be worrying about the lab notebook, and we'll be worrying about a quiz or a pre-lab or something along those lines. But for right now, I'm just putting up 2 assignments on Canvas every week. There will be a presentation. So the presentation is going to be probably on the same date as it's already in the schedule. That's at the end of the semester, so we'll go into more detail a little later. I am probably going to change up the plan for lab exams. I think what I'm going to do instead is have, and this is tentative, I've got to make sure the numbers work out. But I think what I'm gonna have is quizzes in the lab, primarily skill-based quizzes, because that's what you should be learning out of lab. You should be learning skills. So I might have you, when we do the dilution lab, I may have you show me that you can do a dilution, and that would be your quiz for the week. That's the kind of thing I'm thinking of. But like I said, I got to do more thinking on this and make sure the math works out. There is a reading assignment on Canvas that you need to read before you take this week's quiz. So make sure you read that before you go to the quiz. Are there any questions about all of these crazy changes that are going on? It's a little confusing, and it's confusing for me, so I can only imagine it's confusing for you guys too. All right. So what I'm going to talk about today is it's a valuable skill for science. And it's using graphs and images to communicate information. Just realized I don't have the chat. Does anybody, if you look at this graph, what states do you think have the highest confirmed cases of COVID according to just looking at this graphic?
I think the dark red ones.
The dark red ones, can you give me an example?
Washington, Minnesota, Wisconsin.
Yep. Washington, Colorado, Arizona. Does everybody else kind of think that? Anybody have a different opinion?
I'm gonna go with solid red because of California and New York and Florida.
Going with
Sure.
the dark red because
Yeah,
you
that-
already have an idea of which states have the most cases.
Well, it's the most populated, the big cities. So California, New York, Florida, it's where everybody flocks to. So I'm gonna guess for the solid red, regular red.
Awesome. You just brought up two very important points. So first I'm going to say, you're right. Oh, it's not letting me do that. I forget it doesn't let me move this while I'm screen sharing. Anyway, I hid the key, and the key here does say that the bright red are the highest number of cases. But most people are going to look at this and think the darkest color is the biggest number. So this is a bad graphic, because if you look at it, you have to look carefully at the legend to see what exactly is going on. And the second point, that is, I'm just so happy you brought that one up. These are total cases. And of course, the states like California, New York, and Florida are going to have the most total cases because these states have the most total population. I mean, hugely more than any of the other states. So people make these assumptions about color when you use color in graphics. There's another problem with color in graphics, and that is that about 8% of men have some kind of color blindness. So the upper left is what the other 92% of men and most women don't have color blindness very often. That's what we see. These are 3 different kinds of color blindness. You can see that they're all a little bit different, but in all of those, it can be hard to tell the difference between some colors. This one, oh, where am I? This one, I mean, that looks like it's kind of the same color as these, and they're not. So if you can't tell a difference, if you're colorblind, that's my point. When you are making graphs or other kinds of graphics to communicate science, you have to keep in mind things like this, color blindness. So if we're making a graphic, we have to have, I mean, if you use colors, great, because if you can see colors, this is a way to really show the data well. But you have to add a secondary indicator, some other way for people to tell where the colors are, what the different categories are. We'll see this when we go through line graphs in particular. It's just something to keep in mind at this point. So color choice is important. The type of chart that you use or type of graph that you use is also important. This is a pie chart. Pie charts are useful when you're trying to indicate percentage of a whole. So again, this is colored, so there might be some issues here. So that's a problem. But it's, if you can see the colors, it's pretty obvious that when you forget somebody's name, the vast majority of people wait for somebody else to say the name rather than try and guess somebody's name. Some people guess it and get it right. Some people guess it and get it wrong. Once we're in person in lab, the first couple of weeks, I'm going to be right here in this pink line. I'm going to get everybody's name wrong because some of you, I've never seen your face. And those of you who have your camera on, you're not wearing masks. So I'm not going to know who's who. It's going to take me a couple of weeks. But if you're not doing a percentage of a whole, pie charts don't work. So we can do bar charts. Now, this is a complex graphic, but it's a graphic that I think is very, very well done. This part down here is a bar graph. So in this, we are looking at the cost per person for vaccinating dogs against rabies or treating humans with rabies. If you get exposed to rabies, you get a vaccine to prevent it from getting to your brain, essentially is what you're doing. You're trying to stop the virus before it gets to your brain. So that's the cost per person. The left one is for Africa, the middle one is for Asia, and the right-hand one is for Latin America. You can see that for all of these locations, it's a lot cheaper to vaccinate dogs than to treat people who've been exposed. And I also like this little image up here. It's not a typical graph, but it shows you rabies deaths per million people in the population. And you can look at this and very easily tell that Africa has a higher rate of death from rabies. It also has a low rate of dog vaccine coverage. And as we look in these other types of communities where we have more vaccination, we have a lot fewer deaths. The US, we require dogs to be vaccinated for rabies. We have very, very few cases of rabies in humans. It's usually just a couple of them a year. And they're often not dog related. In fact, in the US, the most common source of human rabies is cats, feral cats specifically. All right, so this is an example of vertical bars. The bars go up from the bottom. This is a great default pattern. This should be the first thing that you think about when you're thinking about graphing data. There's some personal preference here. This is good when you're comparing numerical categories. So you've got distinct categories. We're comparing the cost for humans versus dogs. It's not great for showing trends. This is a horizontal graph. This is good. Again, we're looking at kind of non-numerical variables, flavors of ice cream, favorite color, that sort of thing. If we have very long labels, they're much easier to read in a graph like this. If we have a large number of categories, it's often easier to see in a horizontal graph. And if there's a pretty big difference between categories, that's easier for our eyes to see and interpret in a horizontal graph. So if there are significant differences between the categories, that's important. Now, this is land use per gram of protein. This is land use on this axis. These are our categories. You can see it takes a lot more land to make a gram of protein from beef than it does from pork, produce, poultry, eggs, dairy. And then these crops are very protein rich crops compared to most. Here's another thing I want you to be aware of. When you're doing your presentation, if you start showing graphs while you're doing a presentation, always tell the audience what's going on in the graph. Don't leave it up to them to read all of this stuff at the top. In fact, you shouldn't even have this much words at the top if you're doing a presentation. Title is great. Explain the axes. This is a line graph. Line graphs are really good for trends, so changes over periods of time or over concentrations, and for small changes. So this graph is comparing diagnoses of autism to organic food sales. Our axis here, the x-axis, is years. The left-hand y-axis is sales of organic food in millions of dollars. The right-hand axis is individuals diagnosed. So the line for autism is really using this side y-axis, and this is not relevant for that line. The other line, only the left side is relevant. Because organic food sales, there's not an individual diagnosis for autism. We're just comparing two things with the same x-axis. Now, remember when I talked about colors and you need a secondary visual marker? That's what these things are. The boxes and the triangles. That way, even if you photocopied this in black and white or were completely colorblind, you could still tell what's going on here. What is this graph telling us?
Changing something over time.
Changing something over time. Yeah. Changing what? Yeah, you can't answer that question. Always label your axes. That is critically important because we don't know what this means. It could be salary, it could be sick leave days, it could be fundraising, it could be number of employees. We don't know. We also need to make sure that we label our lines so that we know what the different lines are. What's wrong with this one?
It just doesn't really show like a lot of change. Kind of.
Yeah, it doesn't show a lot of change because the scale is wrong.
And
There
it's
is
also wins versus, oh no, wait, wins per year. Okay, never mind. I thought it was wins versus wins. Never mind.
no. All of this area up here is empty space. We don't need it. If the graph was the same height, but it only went up to 25, we'd be able to see the trends much, much better. Now, one of the challenges when we're graphing is if there are huge differences in the results. So this is, again, time on the x-axis. This is the number of internet hosts. So obviously, the internet has grown like crazy over the past 40 years or so. And during the early 80s, there were just a couple of hundred internet hosts.
What's a host? A provider? Internet providers?
More like website providers.
Okay.
So it's companies that have websites on their servers. And now we're looking at over 1 billion of those. That's a huge difference. This is a very hard thing to graph because if we graphed it on a traditional scale, this line would be going almost straight up and we would lose all of the information on this part because it would be squeezed down at the bottom like the last one that we looked at. So if this was on a traditional scale, the line would look more like that. And we lose the fine detail down at both ends of the scale. So this is what's called a log scale. And frankly, these are tricky to look at. But we see down here, the first line is 100, the next line is 1,000, and then 10,000, 100,000, 1,000,000. We're just adding a 0 on, even though the line spacing is the same. It's not intuitive when you look at it. You have to actually kind of think about what's being shown. But if you're looking at something that does have a huge range in values, like between 200 and a billion, you have to use something like this. Otherwise, you're not really seeing anything. All right. Significant figures. Who remembers significant figures? Who hates significant figures? Yeah. Yeah. Significant figures can be challenging, but it is a way to demonstrate how precise your measurement is. So if you've got a ruler and the ruler is marked out in centimeters, when you measure something, you can guess it's 5 centimeters or 5.5 or 6, but you can't get more specific than about half a centimeter. If it's got millimeters marked, then you can say it's 5.2 millimeters or 5.4 millimeters. You can be much more precise. And we use significant figures to demonstrate how precise the measurements are. So these are our 5 rules of significant figures. All non-zero numbers are significant. Zeros between 2 non-zero numbers are significant. Leading zeros are not significant. Trailing zeros to the right of a decimal are significant. And trailing zeros in a whole number with a decimal shown are significant. I'll give you guys a second to write these down. And everybody say thank you to the people who have their cameras on, because I can see how far along they are in taking notes. All right, so let's go through some examples. How many significant figures in that first one?
6.
6. That one was easy. How about 6.022?
4.
4. Anybody know the significance of that number?
That is for moles.
Yes, it is. That's Avogadro's number. If you haven't taken chemistry, you probably haven't heard of it.
Not yet, at least. You will.
You will. It will become near and dear to your heart. What about this one? 0.167.
3.
3, good. How about the first 10,000?
1.
1.
Yeah.
Yeah. Because there's no decimal, the only significant number is the first one, which means we don't know if the actual value is 7,000, 9,000, 12,000. We just know that it's around 10,000. What about the last one here?
5.
5. That decimal tells you that it is exactly 10,000. Good. So what we're going to do now is we're going to go, oops. Hang on. Okay, so here we are in Excel, and we're going to walk through how to graph in Excel. This information is on Canvas, so if you want to print out a copy or if you need reminders later in the semester, it is there for you. So the first thing we're going to do is we're going to look at this data from Switzerland that is the number of deaths due to COVID per 100,000 people in 5 different dates. So how do you want to graph this? Do you want to do bar graphs? Line graphs? Some of each?
Probably bar.
Bar? Okay, let's start out trying bar. So I'm going to highlight the data. And then we're going to go to insert. And there are a whole bunch of options. This is bar. So I'm going to go with bar. And you can see this chart popped up. And I've got why do I have multiple? Oh, I don't. So Excel can be glitchy about some things. And as you can see here, Excel decided to put in the first of the month for all of the months inclusive when my data was only every 4 months. So that's an issue. We'll see if we can fix that. We also see that the y-axis is not labeled. So I'm going to click this plus, and I'm going to say I want axis titles. And then I can highlight the title and go deaths per 100,000 people. Oops. Click on the chart title. I'm spelling Switzerland wrong. Switzerland. What am I doing wrong? Oh, that's right. Probably should add comparing vaccination Um, it's probably a better title for that. Comparing vaccine status. How does that sound? Okay. This axis is dates. We may not need an axis because you can look at that and pretty much tell that it's a date. So let's see. I don't know off the top of my hand how to adjust this scale. And I'm not really seeing a good option here. I could probably find it, but I'll be honest, I would be Googling trying to figure this one out. So how is this looking? What are the problems with it? Besides the fact that we have these dates that are driving me crazy.
Can't really see some of the data. It's too small, it doesn't show up.
Yeah, a lot of the data is too small. It's not showing up. So I'm going to move this off to the side and let's try a line graph instead and see if that looks any better. So I'm going to pick a line graph that has marks for each of the data points. We're kind of seeing a similar problem here that Excel filled in a whole bunch of dates that I wouldn't want it to fill in. What do I need to do to this chart? What should I do with it? Leave it as is?
I would try to change the scale, the y-axis.
Change the y-axis. Okay. That's kind of tricky because the last data point goes way up here. And if we look at the raw data, this gray line is 0 until the last data point anyway. How about clicking on this line and let's format it so we can change how thick the line is, what color it is, or we can add dashes. So that's another way to have a secondary marker. So it's now obvious no matter whether you can see color. I don't want to do that. How do I add this? Man, I thought I had gone through all of this before this class to make sure I knew exactly what I was doing. And now I'm sitting here going, how did I do that?
Are you changing the orange line?
I was looking to see if I could put little markers on the line instead of just dots. But yes, I do need to change the orange line. So that's not a great color. I don't really like it. Let's change the color to red. Oh, it didn't change the color of the line. There we go. All right, so that one's red and it's solid. And the last one is currently gray, which is very, very hard to see. We'll make it purple, and we'll need to do an effect. Actually, that one should probably be solid. Let's change the red one. Here we go. I clicked on more lines, and now I can add markers. Marker options. And I can make them bigger. There we go. Look at that. Now you can see that marker. I just had to keep fiddling around till I found it. Still not a great graphic.
You can make the purple line with like square markers to make it stand out.
Yeah, I can do that. Where did I find that? More lines, marker. Square, and again, make them nice and big. What else can I do to this graph?
Can label the y-axis.
Yep. Label the y-axis. And of course, change a title. Test for 100,000 based on vaccine status. So it's not great because we are looking at some pretty extreme differences out here. But then again, that's kind of the point of this graph. If you are unvaccinated, your chances of dying are significantly higher than if you're vaccinated, especially with a booster. Okay, so that's that one. Let's look at another data set. This is a different data set. This is blood glucose in 6 different individuals. We have a control group. We have a group that was given one type of drug and a group that was given a different kind of drug. And we want to compare these results. We do not need to look at each of these individuals in a graph. What we need to look at is the average. So in Excel, you guys, I'm sure some of you know this, you can get Excel to do all kinds of crazy math for you. You want to get the average, you type in equals, that says formula, average, and then an open parentheses, highlight your numbers, close parentheses, and that gives you the average. And I'm just copying the formula over into the next 2 columns, so I don't have to type it out again. We can find a standard deviation. That's STDEV. All right. Excel doesn't do anything about significant figures. How many significant figures are in these numbers? Or most of the numbers?
3.
3. So we should have 3 significant figures down here. And here. Does that make sense to you guys?
Yeah,
All
so
right.
far.
Yes?
I said yes so far.
Okay. So again, actually, hang on a second. For this one, we're going to make a bar chart with these averages. So I highlight those. I push down my control button and highlight the titles of the columns. And I go insert bar chart. So again, this data was designed to actually demonstrate what we're doing here. It wasn't just me going, oh, this would be more interesting. So again, axis title. This is glucose in, what are the units of glucose? Milligrams per deciliter. And the chart title would be something like blood glucose drug comparison. So this could be a study for diabetics looking at untreated people, people on a traditional treatment, and people on a new drug to see if the new drug, how that compares to an existing drug. Now, because we're calculating an average, we can create error bars on the graph. All right, let me make sure that I am finding the right instructions here. Here we are in the chart design menu. And over here on the left, add chart elements. We can add error bars. And we're going to go to more options. What did you do? You stupid thing.
Excuse me, Professor. For the standard deviation, which one did you use? Was it the P or the S?
It was supposed to be the standard deviation from the table. There we go. So when you just click on that, it just kind of puts up a standard number. It doesn't mean anything. So
Okay.
what I want to do is over here on the right, I've got format error bars. I'm going to click on the custom button. And you have to enter this twice. So right now it's highlighted positive error value. And I'll highlight the standard deviation line. And then click the box for negative error value. And again, highlight the standard deviation lines.
Professor, I have a question.
Yes.
We are making these charts. Do we have to do it through Excel? Like if we have a different computer? Or would you prefer that it's through Excel?
I don't care what program you use.
Okay,
I'm demonstrating in Excel because it's common. And I know how to use it,
okay,
but I know there are lots of other programs. If you go to the Canvas site, one of the other faculty members has got some information about other programs.
okay. Because when I was like pre-reading that today before today's class, it said that like the iOS numbers is compatible with Excel. So I just wanted to see if that was okay to use. with
Yeah.
you. Okay, perfect. I just wanted to make sure.
Yep. All right. You guys have an idea of what we're doing here? I'm getting mixed signals here. This is one of those things, again, it's so much easier to do when I can walk around and have you guys do it. We're going to do that in one of the early labs when we get back in person. We'll go to the library and everybody will get on a computer. Okay. This is another example that's pretty straightforward. So we're going to be comparing blood concentrations. Again, so we're again looking at blood concentrations of an oral medication. So again, it's going to be in milligrams per deciliter. And we're comparing it over 48 hours. Once again, we highlight our selection. We insert a line graph. What did you do? Oh, I did that wrong. Ha. We're inserting a scatter plot with lines. Scatter plots take the first column as your x-axis and the next columns as your y-axis. So we can see the controlled group versus the treated group. I don't know what the difference in between these. What is the control? The control is the traditional oral medication. The treated is a delayed release, supposedly long-acting medication. But you can see it's not getting to the same concentration in the blood. So again, we need to add our labels. Blood concentration of drug in milligrams per deciliter. If you turn in a chart and you don't include the units, that is going to be an issue. I need to know those units. This axis title, it's not clear just looking at the numbers what those mean. So we need to label that one. And we're comparing blood concentrations of drug normal delivery versus slow release. And so we might want to change our titles. We can change our column information and it changes it in the chart. We can change our lines. We can add our markers. And we can make them bigger. And I really don't like that orange. I'm going to make it a darker color so it's easier to see. So here I've highlighted the horizontal axis. I want it to end at 50, not 60. Again, it brings up a menu on the right and I can change so that it ends at 50. That looks better. You guys think you can do this now?
Yeah, I think so.
Yeah, this is one of those things you really need to fiddle around with and try things to make sure that you know what you're doing. It's not as easy as just watching me demonstrate and then doing it. Especially because if you're using something other than Excel, things might be a little different. So that's really all I had to talk about today. It's going to be a very short lab.
So then the next assignment is going to be that we're going to graph something on Excel.
Yeah, the next assignment is about graphing. Yep.
Okie dokie. Has that been posted?
Yes.
Okay.
Yep. Are there any other questions? Okay. Next week, we're going to be talking about transcription and translation. So I haven't read the lab. It was sent to me by another faculty member. But if you happen to have some paper clips, bring them. Because apparently we're going to be, I can demonstrate for you with paper clips, but using paper clips to demonstrate the processes. If you have them.
Next week's lab. You were saying?
Next week.
Okay.
Mhm. Okay. If nobody else has any questions, we'll just pretend that it's 4 o'clock. And we'll call it a day.
I have one question.
Yeah.
I know you asked about using a different program, but a few other teachers that I've had said that there's possibly a way to get like Word through the college as a student for free or for like a discounted price, I guess. And Excel is like part of Word.
It
Yeah.
should be free.
It should be free through the college.
Okay. Is there like how do you get to that?
It's on the VC portal. I can send you a link to it if you want, if I can find it.
Just on like, all right, sorry, have no clue how to do it. And I was trying to download Excel, but it wanted me to create an account.
Oh, yeah. You don't
Yeah, the
want to pay
link,
for it.
the link you go through on the website automatically takes you through like the student licensing. Let me
Oh,
get you the link really quick. Hold on.
Thank you.
Yeah, if you can send it to me, I can put it on Canvas for everybody.
Do you just want me to put the link in the Zoom chat for everyone? Or do you want me to
That
message
works
it to
too.
you?
Yeah.
Okay.
Thank you.
And I think if you go through that link, it gives you instructions as well. Like how to install it and like what steps to take.
Thank you.
Great. I knew there was a way to do it. I was afraid somebody was going to ask that one. I will put the link up on the Canvas page. So if you don't copy it down and decide you want it later, it'll be up there for you.
And it gives you all of the Office programs. So it'll give you Word, Excel, PowerPoint, and all the rest of them. But I only use those 3.
Thank you so much.
Great. Then I will see everybody next week.
Thank you, Professor.
Thank